Hi, this is Mark Kemper with EMS, and in today's video we are going to demonstrate the Creaform MetraSCAN 3D scanning and probing system. Now what this is a system really to scan small to pretty large objects in a single system. You can do both 3D scanning and 3D probing, which we're going to demonstrate here today. So to start off, I want to just show the different components of the system, and then we're going to get it all set up and we'll do some actual scanning and probing. So the system has three main components that you'll use. This right here is the camera system. This is called the C-Track, and you can see there's two cameras, one on each side. Here today we're set up with a tripod, but there's also a very nice shop floor stand you can get for this system, because this system is able to be used right out on the shop floor for metrology, scanning, reverse engineering. So if you're going to work in a shop environment a lot, there's a really nice stand you can get for it. It has a battery backup system and some other nice features. This is the tracking system, as I mentioned, called the C-Track. And then this is the scan head for the scanning. This is a laser-based 3D scanner, and we'll go into more detail on this, but this is the actual scan head here. And then finally, this is the probing system for probing, and it's standard Renishaw M4 type connection, so you can use different extensions, different tips, etc. for this system. So that's the probe itself. So those are the three components, and then there's a controller sitting on the floor that everything plugs into, and then of course you're going to drive it off a computer. Typically that's going to be a laptop, as you see here. There's also a rolling toolbox that some people like to get, where they can put the laptop on it. They can actually attach the C-Track to it and roll around with it. It's got a large monitor. So that's another nice option if you were going to use it on the shop floor all the time. So let's start by talking about the C-Track itself and what it is and how it works. Now the C-Track is a camera system, and there's basically two cameras on either side, and around these camera lenses are some infrared lights that pulse out basically a light. And what that's going to do is that's going to either track the scan head or the probe itself, okay? And it's going to track it in space. And what that allows you to do is scan, very large objects. Basically, you have these cameras, and basically where they converge, where the two cameras kind of share the same space, anything in there, meaning the C-Track, the MetraSCAN or the HandyPROBE, it will track it in 3D space, okay? So how it does that, if you notice on here, you see all these different round circles, or targets as we call them, or reflectors. Those infrared lights are shining out that light, and these are retroreflective targets and lighting them up, and the camera is seeing them. Now why you see so many on here is no matter what position I'm holding this in, the C-Track system should be able to see the targets on it. Okay, and for the probing system, it's similar, and you can see again there's a series of targets that it's looking for. So as long as you're moving along to your part, which we're going to have a part here in a minute, and you're probing points, as long as it can see these sets of targets, it can record, in this case, a point, or with the laser scanner we're going to actually be collecting lots of points. Okay, so this system has a 16-meter volume. What does that mean? So it kind of fans out in a cone shape. There's a standoff distance, so about 4 feet away before the two cameras can kind of start to see the object. And then from there it goes out quite a ways, but it's a 16-meter volume. So almost the size of basically like a small car. That allows you to scan without having to move the object or move the C-Track itself, which we'll explain that in more detail later. So basically in a single setup, you can scan very large objects in a single setup. So whether it's scanning or probing, as long as it can see this head while you're scanning, it'll be able to scan it. Now let's talk about accuracy for a minute. So This is what's called the C-Track Elite. This is the highest accuracy model. There's 4 different models. We're not going to go into a ton of detail. There's a standard and an elite, and then on the head itself, there's a 350 model, the scan head, the 350 model, and the 750 model. So the elite is the more accurate C-Track. The 750 model, which we're going to demonstrate here, has 14 laser lines versus the 350, which only has 6. This also has a single line mode, which I'll demo here in a minute, that lets you get into deep cavities. This is similar to the HandySCAN setup, if you're familiar with the video we've done on that, both the 300 and the 700. Very similar. In fact, it's almost a shrunken HandySCAN inside here that's kind of built with this ball around it. So it's similar in that sense. Okay. So the elite system, let's talk about accuracy. The elite system that we're showing here, in that 16 meter volume, you have what's called a volumetric accuracy of just under 80 microns. Now, what is a volumetric accuracy? That is, if you took measurements anywhere within that volume in 3D space, everything within that volume would be within under 80 microns. It's 78 microns is what it's been verified to. So that's a very, very good accuracy in a very large volume. Okay. The same for the probe. As far as probing in that volume, you're going to have that same accuracy. Now, point-to-point repeatability on probing a couple of points, you can be down in the 30 micron accuracy. Okay, but your true volumetric accuracy, measuring anywhere in that volume, you're under 80. If you were measuring single point repeatability, for example, in kind of a linear thing, you can easily see 30 microns. Now, we have a certified ball bar, and we've measured things down much lower than that, sub 10 micron on points. But if you want to, kind of a real-world accuracy within that whole volume, that 80 micron accuracy is a good number to look at. So very, very good. Now, what we're going to do is we're going to go ahead and set up a part, and we're going to walk you through doing both scanning and probing, and then we're going to also talk about a feature called dynamic referencing, which we haven't talked about yet, but very, very powerful tools for shop floor metrology, where you can have harsh conditions such as noise and vibration and things like that. You're going to see some things with this system you can't do with any other system. So we'll go ahead and get everything set up, and we'll get into the actual demo. Okay, so let's get started first by actually showing that scanning volume. So I've got a TV here so you can kind of see what we're doing, and we've moved the C-Track back there by the camera. And if you look on the screen, that cone shape represents the volume, that 16 meter volume. And you can see over here where the actual C-Track is sitting in relationship to the volume, and then you can actually see the scan head. So if I walk up here, you can see it's about 4 feet away from the C-Track system, and I can go all the way back beyond where I can reach, all the way over up here, and way over here. Whoop, and still have our scanning volume. So again, it's a very large volume, and you're going to see shortly with dynamic referencing how that volume is almost endless because we can move around. We'll start in what's called static mode, and I'll explain more in a minute, and we're going to just scan. Now, what I've got here, it's a subframe off an automobile, so this would be a very typical type of part we might be scanning or inspecting in a shop floor environment. So again, this could be reverse engineering, or it could be shop floor metrology and inspection. So we'll first do some scanning on it, then we'll do some probing. And let's talk about the actual head itself. So here's the scan head. It's very lightweight, even though it looks quite large. It's very lightweight. Only weighs a few pounds, and it's actually got some interactive buttons on it. So while you're scanning, there are things you can do with these buttons, and there's also some color readouts. Okay, so right here on the scan head, you can see we've got different buttons, and they do different things. You can see I can scroll through and do things like zoom in, zoom out, calibrate, adjust the laser power and some different things, which I'm going to talk about. So a lot of the things are accessible right here on this system, and that's right here on the handheld scanner, which is really nice, so that you don't have to walk back to the computer to do most things. So I can start and stop the scanning like you see here, and again do different things. Okay, so let's go ahead and get started and we'll do some scanning. So this is the third generation of the MetraSCAN system. It's been around for about 10 years now. So this latest system just further enhances the technology, primarily in the scanning speed and the accuracy, ease of use, things like that. So to get started, we're going to again scan this part, and I just simply click the button and you can see it'll start scanning. Okay, so as I mentioned, some of the things I can do is zoom in, zoom out. Okay, and you can see just how quick. There's 14 laser lines here, and you can see how fast I can scan. So it's incredibly fast. Now the other thing you can do is you can adjust the laser. Okay, so for example, let's zoom out, and we are going to crank up the laser speed. So right now it's kind of at the lowest setting. So when we get into dark and shiny stuff, we're going to want that laser to be more powerful. So this part is dark, it's got some rust on it, and you can see I just quickly changed the power of the laser so the laser lines are stronger, and you can see how fast. Now as you go stronger and stronger, that will slow down your scanning speed, because that also has to do with the cameras, the sensors. They need to slow down too. But again, you can see how quickly I'm able to scan this. Now you'll notice on the screen there's kind of a picture of the scan head, and right now it's showing 100%. That's basically the C-track and the view. So for example, if I were to put my body in front of it, you see it stops scanning because it can no longer see the C-track. So that's the one thing you just got to kind of be cognizant of as you're scanning, is just kind of keeping your body away from it as far as with the C-track itself. Okay, but I can start and stop anywhere. I can walk over here and continue scanning. So that's really the nice thing. Basically anything in this volume I can scan. So I can go wherever I need to go to scan this. Okay. Now we're in what's called static mode. So this is fine if I want to set something up and scan it. The problem with this setup is I can't move it. Okay, I can't move the part, and I can't move the C-track because it'll lose the relationship between the two. And that's typical of a lot of your other scanning systems, your ARM-based systems, a lot of your tripod-mounted systems. The part can't move, and the scanner can't move, or with an ARM-based system, the base can't move. Obviously the ARM moves, but you can't move the base. And that's a real problem. So if you look at this part, I can't get underneath of it, and I can't get all of the back. I mean, yes, I can come back here and kind of reach around, but I can't get all of it. Okay, and if I were to move this part and then continue scanning, you're going to see what's happened, right? So now the data is not lined up anymore, right? So we've lost the relationship. Okay, so now for some parts, it's something really easy. We'll set up this static mode and scan. But probably 95% of the time we introduce this thing we call dynamic referencing. Okay, so we're going to go ahead and set that up, and then we'll talk more about that and how it works. Okay, so now we're set up for dynamic referencing. So I'm going to walk you through what we did and how we set that up. Now what's included with the scanner is a set of other targets. Okay, so we already talked about the targets on the scan head and the probe head, but you get another set of targets, both magnetic, and then you also get rolls of targets. Now these targets are a little different in their size. These are 12mm targets, where on the scan head we have 10mm targets. Okay, so what that allows is the camera system to differentiate between two sets of targets. Okay, so with this kit and the box of stickers you get with it, we can add targets to our part and then track our part. Okay, so that allows our part to move, or our C-track to move, and as long as it can see the targets, then we're good to go. So let me show you what I did. And again, you can use a combination of swivel, magnetic, or or the sticker targets. So I've added on some swivel targets, and it's just a base with that 12mm target, and it swivels. And again, those are very strong magnets. And then I've also put on these, which are just kind of a flat one. So what is the difference? Well, just like the scan head, the camera, the C-Track has to see these targets, and you want them random, okay? You want them to be random. You don't want them evenly spaced, and that shouldn't be a problem. It'd be very difficult to do that. But we've randomly placed these targets on here, and I've added 3 swivel targets to the top. Those are good when you're doing a large object and you need to move the camera system around, let's say, to the back side, because then what I can do is I can turn these targets and the camera will see them, and because it has 3 of them and it knows the center of rotation on these as swivel targets, it again can triangulate position. So if you've watched any of our videos, you know we've talked about triangulation, and that's how these scanners work. Same with the C-Track system. So having 3 or 4 reference points will allow it to target its position. So what I'm going to do is I'm going to swivel these back. And the first thing I have to do is tell the system to look for these targets. We need to identify them, okay? So I'm going to come over into the software, and I'm going to say find the targets, and I'm going to window in on these targets, and I'm going to hit accept, okay? So if you look now, let's move our scan head out of the way, and it may be hard to see on that screen, but it is identified, if you look there, it's identified 10 targets, okay? So right now it can see 10 of 10. So for example, you see there it says 9 of 10, and then 7 of 10, 8 of 10. So as long as it can see at least 4 of these targets, we're going to be able to use this dynamic referencing I've been talking about. So let's go ahead and get started and do some scanning, and then show the dynamic referencing. And as far as how the scan head works, you basically have 2 cameras here, and then you have the laser here. So this is where we emit the laser stripes, and then these cameras are actually picking up that 3D shape. Okay, so the C-Track only sees the head itself. Okay, it doesn't look at the laser lines. It doesn't understand even what they are. All it knows about is this scan head and now these reference targets. The scanner itself has 2 more cameras, and where the lasers are emitted, and that's picking up the 3D shape. Okay, so it's kind of 2 different operations. One is tracking it in 3D space, and then these sensors are measuring the 3D shape. Okay, so same thing. We will go ahead and long hold to tell it we want to get ready to scan, and we'll start scanning. Now, since we reset, let's go ahead and zoom in so you can see what we're doing. And let's go ahead and crank up our shutter a little bit. There's an automated way to sample the data or sample the surface to adjust the lasers, but I can just as quickly do it right there on the fly. Okay, so now you can see we're scanning just like we did before. You can see how fast we can scan. Okay, we're moving around the part. Okay, so let's go ahead and grab some data here. Okay, like we did before. And again, I have that huge volume to work in. Okay, now let's do something that you can't do on almost any other scanner, and that is move the part while you're scanning, and yet things are still perfectly aligned. Okay? So think about that. If you're out in a shop floor environment and you've got noise and vibration and things moving around, you notice how it's tracking those targets? Okay? You don't see that scan data moving off in outer space anymore. Okay? So that allows us to move that C-Track system or move the part to scan. So for example, I want to start getting around on this side. Again, as long as it can see the head and it can see those targets, at least 4 of them, we can continue to scan. So that's why it's got this huge volume with such a good accuracy, is by using that dynamic referencing. Okay? So let me get a little bit more back here. Okay? And now we're going to do something, again, that's very unique. Now, I'm going to take these swivel targets off because I'm going to flip the part over and continue scanning. So normally I wouldn't put these targets up here, okay, because of what we're about to do. But normally on large objects where I'm moving the C-Track around, I would do that. And I'm going to put them back here. I don't want the C-Track to be able to see them and get confused. So let's set our scan head down. And let's move this out of the way. Okay, so you can see it says 6 out of 10. So it still sees plenty of targets for us to continue scanning. Okay? So now you can see what it's doing. Okay, now we're filling in the backside all the way around this part. Now we've got a little bit of table data in there. A lot of times I'll put the part slightly up in the air just so I don't get it, but that's a very easy thing to delete. If you've watched any of our other videos, getting rid of what we call scatter data is very, very easy. But you can see what I'm doing. This is a thin sheet metal part, and I'm filling in all the areas I didn't get. Okay? So again, on traditional, let's say tripod mounted scanners, you know, this would take you a few hours to scan a part like this. We can scan this whole part in probably 10-15 minutes. Okay, so it's pretty incredible the speed of this, and again, do it very, very accurately, and even while the part's moving around, you can see how it's tracking it. So those 14 laser lines give you this huge area you're collecting data. And then the same problem with an ARM-based system. You can't move the base, you can't move the table, everything has to be locked down. Any kind of vibration, any jiggling, any moving, and your accuracy starts to go out the window. Also, when you're doing large parts, you got to do a process called leapfrogging, or do multiple scans with overlapping data and then aligning it later. So both of those take time to do. This will do it, you know, much, much faster than anything else out on the market. And then one other thing is I'll go to that single line mode. And here, I'll do it on the front where you can see it. And what this allows you to do is it orients one laser perpendicular to those sensors and focuses in everything on that for scanning. So that's great to get down into deep holes and cavities and things like that. So it's a really nice tool. And again, I can switch back at any time. Okay. Okay, so that's dynamic referencing. So just to kind of review that again, you're adding targets typically right onto the part, either a sticky target, magnetic, or a swivel target, and as long as it can see at least 4, and you can have as many as you want, 8, 10, 12, 15, kind of just depends on your part. It's a nice tool because, again, any movement of the part, the camera system can track it. Okay? So next, let's go ahead and show some probing, and then I'm going to show you some other cool things you can do with the scanner. Okay, next we're going to show probing, but what I'm going to do first is I'm going to do some 3D scanning. Just we'll get some scan data on the screen, and then we can show the probing because you'll kind of see how the two work together. So again, I've just reset it up. I've done my dynamic referencing again, so I've identified those same targets. Okay, and I'm just going to kind of fill in some data here. And it's kind of like digital spray painting. You can keep going over and over. It's not going to hurt. You know, scanning. You hold the scan head about 8-10 inches away. That green bar on the left side, if you get too far away or you get too close. You've also got readouts right on the scan head if for some reason you couldn't see a screen. But it's pretty easy. I mean, you don't have to be perfect. You know, 8 inches, 10, 12 inches, just as long as it's within the focal range of those cameras, okay? So there we go. So that's enough. Okay, so we'll hit stop, and we'll stop the scanning, just so we've got something on the screen. And then we're going to switch over here to probing. So what it's doing right now is processing the scan data into a polygon mesh. Okay, that's the native format of most scan data. So if you look at this, you know, it's not a CAD model, it's just scan data. And again, we've got other videos that'll go through that whole process of going from scan data to CAD data. But this is just polygons, so think of like an STL or an OBJ file. Okay, it's not CAD. There's a separate process, separate software to build CAD from scan data. But again, so what you're looking at is the mesh here. Now this is a stamped part, sheet metal, and it's got a bunch of holes in it. Why people like to use probing, one of the main reasons is holes. When you're scanning with a scanner, there's not a lot of depth to this hole, right? This is a little bit thicker metal because it's a frame, but the scanners never scan a sharp corner, right? You just try to get more and more points to try to kind of define that corner. but when you have a nice big deep hole, you'll get plenty of scan data kind of on the walls or the side of that hole. With sheet metal, you have very little there, so it's hard for the scanner to pick up a lot of data there. So that's why people like to use a probing system, because they can go in and probe the holes. Same with planes. So a lot of your shop floor metrology uses probes. Now, think of a CMM. That's all this is, right? But it's obviously not a big setup with a granite table. This is handheld, but essentially, from here down, it's a CMM. And again, it's very portable, and we can use it out on the shop floor. And again, similar to an arm, but without the physical arm, we can do this all optically. Track it. Okay, so let's go ahead and tell it we want to do some probing, and we'll show that. Okay, so we've gone into the probing here, and the first thing we're going to do is create a plane. So if we're going to do any kind of circle or cylinder, especially circles, you definitely want a plane first. So let's start up here, and you can see now when I'm using the probe over here, you can see the XYZ readout. So it's tracking again where it is in space. And again, I can see my 10 of 10. That's my dynamic referencing points. So I simply just come in here, I put the probe down, okay, and I click the button. Okay. Now, technically I need 3 points to create a plane, but I can go around and create as many as I want. And then once I get it, I can long hold it to create that plane, okay? So once I have that plane, I'll hit create, okay? And if we zoom in, you should be able to see right there that plane I created, okay? Now, if I was doing inspection, we might be using a product like Polyworks or some other software. We can actually do live probing and inspection. We're not going to show that today. I'm just going to probe some geometry, for reverse engineering. But it's the same concept. If you're doing inspection, it would be saying, hey, pick 4 points, create a plane, pick this circle, 3 or 4 points to create a circle, and then it's going to give you some inspection readout like pass or fail or things like that. But again, it's the same process. I'm just going to probe because we could use it for reverse engineering as well, okay? So I've created that plane, and now let's go ahead and let's do a circle. And we're going to tell it to use plane 1 as reference. And then we're going to go in here and just pick. And again, you can see it's all interactive. And at any point, once I have that, it's going to create that for me, okay? So let's zoom in here, okay? So now I have a plane and a circle, okay? So what I can do now, and I would just go around and probe all of the holes, planes, circles, lines. Usually for probing, you're doing prismatic geometry. So it's lines. That could be like scribe lines, or something etched into the part. You're going to do holes, you're going to do slots, squares, planes, cylinders. It's basically primitive geometry. The other thing you can do is sometimes in aerospace and automotive, they'll have a coordinate system for tooling already predefined on that tooling, and you can actually go in, whether it's tooling balls or something else, and actually probe it ahead of time, set up a coordinate system, and then do additional probing or scanning, and then everything is related to that system. Okay, but that's really it. It's very easy to do. Now again, same issue or same advantage. Okay, if I hold this here and move this around, you notice it's not going anywhere because it's tracking this part in space. So even though I'm moving it, or I could be out there, with vibration or other things like that, this will accurately track both the part and the probe, so it doesn't matter if the part moves. It doesn't matter if I move the C-track. I'll still get that very, very accurate measurement because of this dynamic referencing system. So it's really, really unique system. So I'm going to show one more pretty cool thing that you probably won't see in any other scanning technology. We'll get that set up and show that next. Okay, so what we're going to show next is something that we hear common complaints about because traditionally most scanners do not like very dark or very shiny surfaces. A lot of your structured light systems really have a hard time with it. Most laser systems have a hard time with it. This new MetraSCAN system, in the way it works and the ability to do the high power lasers, allow us to scan things like chrome without putting any surface treatment on it. What I mean by surface treatment is typically we would dust the part. It's a spray. It typically wipes off, but you know, there's certain things customers don't want us spraying with this stuff, such as electronics, or you know, we've done some very expensive exotic cars, or you know, rare costumes or rare relics or things like that, and they don't want any kind of spray on it. For a lot of parts it's fine, but it is an extra process, and if you're using targets, you gotta put the targets on and then spray it and then wipe off the area for the targets and then do the scanning and then clean it all up. So let's put this down, and again, I'm not going to use, I'm just going to use the static mode for this and watch what happens here. And let me zoom out a little bit, kind of zoomed way in, there we go, okay? So this is scanning chrome, okay, without any surface treatment at all. Okay, so chrome is highly reflective. This part has lots of curves to it. You got to kind of hit it, you know, pretty perpendicular to get a return. So you'll kind of see me, you know, moving my, and that's the beauty of this system, is it's so easy to move around. Scanners like to be perpendicular to the surface they're scanning. It's just like the digital spray or spray painting, and I call it digital spray painting. But you can see we are scanning chrome, okay? So again, this is pretty much unheard of in any other scanning technology. The ability to scan chrome, okay, with no surface treatment whatsoever, okay? So you got to go a little bit slower because I've had to crank up this laser power, which means I got to slow down the sensors. That's essentially the capture rate of the scanner. But you can see this data looks very smooth, you know, very nice. We'll zoom in a little bit here, okay? And if I stop, now while we're scanning, we're kind of in this preview mode. So it's kind of a rough representation of what you're scanning. When you actually hit stop scan like I did now it's actually taking all that raw point cloud data, because that's all scanners are underneath our points, and it's turning it into scan data. But you can see, turning it into polygon data, so you can see how nice that looks. Now again, I got the table, but I'm not worried about that. As I mentioned earlier, I can slide that button there called remove isolated patches, and they're all gone. Now I got to fill in the rest of the areas, but again, you can see how nice that data looks from you know, basically raw chrome without any treatment. So that is a really nice feature. It also has a mode called HDR, and it'll actually, you can set two, a high power and a low power. Another problem you have is when you're doing black to white, or you know, light to dark, you usually would have to tune the scanner for the dark, scan all the dark, then tune it for the light and scan all the light. With this, it's got this what's called HDR mode, and it basically pulses back and forth. So if you have parts of varying color, it'll scan it all in one pass. So that's another nice feature of this system. So just to kind of wrap this up, this is the new third generation of the MetraSCAN system by Creaform. It's an optically tracked system for both 3D laser scanning and probing, and you can work back and forth. Some people just do probing, some people just do scanning, some people do both. There's a few different models of the system, as I mentioned, and you can go on our website and see more about the different models and the different accuracies and stuff. But very, very accurate. It's got a very large scanning volume, and then again, when we use the dynamic referencing, that scan volume is almost limitless, because I can move that C-track around, I can, you know, move the part around and get all the way around a part. You saw me flip the part over and continue scanning. So very, very nice system, whether you're in a lab or out on the shop floor. You can get a nice rolling toolbox and a nice shop floor stand for it, and use it. So very, very accurate, very easy to use, very, very fast, and the dynamic referencing. So it's a really powerful system.